What we have is this, guys. Show that the pairs of lines and curves do not have an intersection. Which 30 part 2, is it? Okay. What usually happens is we have a curve of some variety. The second equation represents a line. And what usually happens is the line will hit the curve in 2 spots. When that happens, we get a quadratic equation, something like this at the very end. We'll get something like that. And we'll solve it. Go, oh look, it's x minus 3, and then x plus 1 equals 0. Then we say, look, it's x equals 3, x equals minus 1. Then we go and find the y values, right? That's what usually happens. Now, there's another scenario where the point only hits it once. When you get a scenario like that, what happens is this. When you have a scenario where it only hits it once, so you're talking... a second, I'll just make this a bit easier. Back up again. Okay, it only hits it once, right? Now, in the case where it only hits it once, what you're going to get is an equation at the end, something like this. You'll get x squared plus 4x plus 4 equals 0. And you'll be like, reference number is 4, which is going to be x plus 2 by x plus 2 equals 0. And then you only get one value of x, and hence only one value of y. That's when it hits it once. Then we have the third scenario where it doesn't hit it at all. In cases where it doesn't hit it at all, you can't actually do the question. The question is actually impossible to do. So an example would be something like x squared, I don't know, plus 1x, then plus 29. You get an equation like that. You can't get the reference number. When you do the minus b formula, what happens? It'll give you a mad error. So the square root of b squared minus 4ac, this part of the minus b formula just doesn't work. You'll get the square root of a minus number. And square root of minus number at this point in time in our course doesn't work. Is that alright? So, with all these questions in question 20, that's what's going to happen. So we do our usual routine. We label the quadratic, which has x squared and y squared. We label the linear. Using the linear equation, get one letter on its own. Which letter will we get on its own? Why did you choose y? We don't have to deal with a fraction. Y goes that side. 2x plus 3 equals y equals 2x plus 3. You could also do you could also get x on its own, have a fraction, and sub it in that way as well. You'll still get the right answer, but it'll be just considerably more difficult. So if you were to get x on its own, just for argument's sake, you'd get 2x equals y minus 3. X equals y minus 3 over 2. So you'd substitute this in for x into the quadratic, or you can substitute this into y on the quadratic. It doesn't matter which one you do. But look, it's obvious which one's easier. So that's the easier one. What is the quadratic equation again? 3 times x squared plus whatever y is squared equals 1. Is that right? What's y? 2x plus 3. Okay, so what does that mean? 3x squared plus 2x plus 3 multiplied by 2x plus 3 minus 1 equals 0. Okay, what happens next? Plus 6x, yep, some of you got that there. Plus 9 minus 1, and I forgot the 3x squared at the front, didn't I? 7x squared plus 12x plus 8. Now, it's not going to have a reference number. The reference number is 56. That's like 2 and 28, 7 and 8, 14 and 4. None of them make 12. So I go straight for the minus b formula. I say, look, a equals 7, b equals 12, c equals 8. Minus b is minus 12 plus or minus the square root of b squared, which is 12 squared, minus 4 times 7 times 8, all over 2 times 3. Oh, sorry, 2 times 7. I get minus 12 plus or minus the square root. It's going to be a minus number. Or is it? Is it math error again? Oh, yes. 12 squared minus 4 bracket 7 bracket 8. Just be aware, do you know when you're writing 12 squared, yeah? Put the 12 in brackets, because if that was minus 12 squared, the answer could come out wrong. So I'll explain that in a second. The answer is minus 80 there, isn't it? And that's, so then you say, look, no points of intersection. Does that make sense? Because you can't solve it. Yes, Luke?